Accidents are not inevitable. They can be prevented. Conservation of the Air Force and its combat capability makes it essential to probe the causes of accidents, which in a matter of seconds can turn the product of thousands of man-hours into scrap metal and destroy the hopes, the skills, and the lives of its crews. Scientific investigation and analysis of accidents reveal there are two major causes: human error and materiel failure. And in the final analysis, even the materiel failures can be traced to human error. Most of these errors are not a result of willful negligence or violation, but of a man's failure to act on what he knows. Sometimes we find these errors begin with the initial requirement for a new piece of equipment, or in the process of creating the design. Although the design may be correct mechanically, it is difficult to anticipate all the possible human ramifications which may affect it. Sometimes we find these failures in the manufacturing process, installation and testing, or in the writing and interpretation of procedures for maintenance, and finally, in operational use. In the early phases, when the equipment is new, the greatest source of error is functional or structural breakdown, materiel failure. In time, as the bugs are taken out of the system, the major cause of accidents becomes human error. It does little good, however, merely to say that an accident is caused by human error unless we explore what error, under what conditions it occurred, who committed it, and why. Human failure occurs in three major areas: communications, human limitations, and supervision. Accidents result first when vital communications break down. Second, when the demands of a situation exceed man's limited physical, physiological, and psychological capacities. Third, when the integrating function of supervision fails. Man seldom works alone, and this brings into focus one of the major sources of human error: communications. Man's great progress and his fantastic development in cultural and social fields, as well as in material achievement, has depended on his ability to convey his ideas to other men. But any communication is difficult, because even a simple object like a tree has many different characteristics. When a man tries to describe it to someone else directly, with words and gestures, he frequently fails. The problem is even more difficult when he tries to express abstract thoughts or physical properties such as electricity. The communication of mathematical concepts can be even more difficult, but the problem is further complicated when communication is written or indirect. To help matters along, man has developed symbols, which are a compression of words and ideas with previously agreed upon meanings. The problem is still further aggravated in the highly sensitive area of human relations, where the same words mean different things to different people. And the greater the number of stations in any communications chain, the greater the chance for error. If you want your communication to be accurate, check with the source. There have always been tremendous barriers to man-to-man communication. But today, another factor is becoming increasingly important: the communication between man and machine. A large part of it is carried out on a simple, direct man-to-machine basis, through man's sense of hearing, sight, and touch. But as man ventures into new environments, his communication with machines becomes more complex. He has to derive information from many sources at once. Information about speed, location, altitude, And this information cannot be verified directly by his senses. Today, man's life more than ever before depends on this complex man-machine intercommunication. The structure of his communication is vital. And he must be aware of the soft spots where communication is likely to break down. For even simple ideas or orders may be misinterpreted due to insufficient information or too much information that overloads the system and exceeds man's limited ability to absorb it. These are simple things, and we are all somewhat aware of them. But unless we clearly understand and accept their implications, they may be the beginning of disaster. Sometimes the failure is due to a lack of sympathy between the sender and the receiver, or a lack of sympathy with the information being received. The receiver unwittingly distorts the meaning of the information because he is emotionally unwilling to accept it. We frequently hear only what we want to hear, as this nursery rhyme demonstrates so well. Old lady, shall we go a-shearing?
What did you say, sir? I'm a little hard of hearing.
Beautiful lady, oh, beautiful lady, I said I love you dearly.
Thank you, kind sir. I hear you very clearly.
Since man needs information before he acts, the lack of clarity sets the stage for mechanical and human failure. Communication breaks down very fast and very often when it isn't clear, when it's garbled. This garbling can occur in many ways, technically by interference or background noise, through poor enunciation or illegible writing, by not being in the proper form or the right channel. All simple things, human errors that cause the loss of valuable men and machines. Behind each potential accident lies a cause or series of events that can be identified and eliminated. The purpose of the Air Force Safety Program is to identify these cause factors and prevent them from spelling disaster.
It had been raining for a couple of days, and when the rain finally stopped, it was one of those dull, dreary mornings. I've always had the feeling that the weather has a lot more to do with a man's mental attitude than we think. So today I was taking a little more interest in my men than usual. I was particularly concerned about my co-pilot. He's from New England and not given to much conversation. His father died about a week ago, and it hit him pretty hard. I tried to start a conversation a couple of times to see if he had something he wanted to get off his chest, but, well, the moment never seemed right. He just didn't feel like talking. As the big bird gathered speed on the runway, I turned to him. For the first time that day, he looked me in the eye, so I smiled and said, "Come on, cheer up." And in a split second, his hand grabbed the landing gear lever, and I heard him say, "Roger, gear up."
This is the resulting damage to the aircraft. The communication was direct, man to man, and it was well-intentioned, but it wasn't clear. The Major's thick Texas accent combined with the background noise during takeoff and the preoccupation of the co-pilot to distort the communication. Here at the Air Force Safety Center, accident analysts process many reports like this. They come from every base and cover every area: flight, missile, ground, and nuclear. If errors in communication can occur when one man sits right next to the other, how much more care must be taken when he communicates indirectly with other men through the medium of the printed word? There is a sea of paper, and a man has to stay on top of it, evaluate its information, absorb it, organize it, file it, and then be able to find it before he acts.
I knew a piece of paper on C-130 refueling was here somewhere. I'd seen it with my own eyes. I vaguely remember there was a kind of caution on it. I never let something like that get away from me. I'd gone through these refueling tech orders 3 times when the phone rang. It was the colonel. He wanted to know what the problem was with the refueling. Why weren't we getting with it? I told him I thought there was a new tech order on it, and I wanted to check first, but I couldn't seem to find it. He said, okay, find it, but remember, I have to get this bird in the air soon. Well, after that call, I began to feel the pressure building up. I figured it couldn't be that important. I'd certainly have remembered it. Besides, I'd performed this operation many times. I felt the procedure couldn't be that different. So I told the airman to keep searching while I went ahead with the refueling.
The tech order had a red caution on it that said, make sure the vent plugs are removed before refueling, or the high pressure will rupture the wing.
We were in the process of refueling, and things were going along okay. And the airman came running out of the office with that all-important piece of paper. But he was too late.
The communication was clear, correct, properly directed, but unavailable for action because of a simple human error. The communication was accurately labeled and properly filed, not under refueling, but defueling. The sergeant misread the label, though he knew what it meant. There are times when words don't mean what you think they do. Take the words high pressure. Some new automobile tires are advertised as high pressure. This means 32 pounds. These airplane tires are also high pressure tires. But here the words high pressure may mean 300 pounds. This gauge has a low pressure line. Here, low pressure ends at 600 pounds. The high pressure line goes to 3,500 pounds. The airman, called in from another shop to lend a hand, goes on his past experience and fills the tire with the high pressure line, with this result. Be sure you know what the communication means before you act on it. A vast amount of communication takes place between man and machine, from a device you can carry in your pocket to Telstar, and to this huge man-machine complex.
This machine communicates information to me about the missile in flight. At the same time, other machines direct the missile. If the information it gives me says the missile is off course, as the range officer, I will destruct it. During this operation, the machine indicated to me that the missile was coming uprange, right at us.
This was a unique accident. At the time this missile was destructed, it was actually on course. It was receiving and acting correctly on programmed information. However, the strip recorder gave exactly the opposite information to the range officer. This happened because the day before the launch, the strip recorder had been calibrated on the wrong frequency, 180 degrees out of phase. Before a man acts on information from any machine, he must be certain the machine is functioning correctly. But that alone is not enough.
As I can tell you from bitter experience, there's a lot of turbulence that night. I'd made 3 passes at the field, but GCA could get no target on the precision scope, and my fuel was getting low. I tried a VOR approach with radar assist. But that didn't work. I climbed to what I thought was 7,000 feet, leveled off, and ejected successfully. It wasn't long before I realized what my error had been.
The pilot was upset by the fact that GCA couldn't help him, and this, combined with the turbulence, made it difficult for him to read the altimeter accurately. He had, in fact, ejected at 17,000 feet. He had made a 10,000-foot error. Errors like this are not uncommon. A man must know the limits of his machine and take the necessary time to get an accurate reading. A machine can't follow up to see if the communication was received accurately. Sometimes a communication can be clear, accurate, properly directed, the right person receive it, understand its meaning, and still ignore it because the information is emotionally unacceptable. This pilot had a great day on the target range, and he had followed all the safety communications when he was up there. But here on the ground, he ignored a safety communication which clearly states that motor scooter helmets must be worn with the helmet strap fastened. This should have been a minor accident, but instead the man died an hour later at the hospital. Not as a result of a hazardous act in the air, but because of failure to accept a simple directive on the ground. The Air Force goes to great lengths during an operation to keep you informed and in constant touch with each other. But sometimes, out of boredom, overconfidence, or laziness, a man will recklessly cut off this vital communication with disastrous results. This should have been a routine armament check, except that the crew chief brought out a faulty cord. And as far as he was concerned, it was too much trouble to go back to the shop to get a good one. So he cut off his communication. Only for a minute, he thought. In the cockpit, the mechanic assumed that his crew chief and the others were still in communication with him. Before hitting the switch, he made his usual routine communication check. Bombay clear. Waited, but failed to demand a response, ensuring his transmission had been heard. The Bombay doors closed, killing the crew chief almost instantly. At 19:10 hours on the 18th of September, 1961, a student crew departed Carswell Air Force Base, Texas, on a routine training mission in a B-58 aircraft. This student crew was composed of members of the 1st B-58 wing in the Air Force.
I was in command of this flight. Prior to it, the crew had flown only 6 times in this aircraft with a total of 32 hours flying time. We had accomplished 2 daylight air refuelings and 1 night air refueling.
During the takeoff, I noticed an orange glow behind the aircraft, but thought nothing of it. The navigator, however, reported fire, which was confirmed by the defense systems operator. I immediately attempted to raise the gear and then contacted the tower to request instruction. The tower indicated that a chase aircraft was being launched to inspect the damage. As I had never received a safe gear indication, I attempted to lower the gear. By the time the pilot rendezvoused successfully and contacted me, the flame was out. The landing gear indicated down and locked. He said he was coming in close to get a look at the landing gear. He reported it was too dark to determine the full extent of the damage. They suggested that I fly over the city of Fort Worth so the lights below would help give him a better view. Over Fort Worth, he communicated that the left main landing gear was hanging at an angle of 45 degrees and that the wheels appeared to be damaged, but he still couldn't see clearly. But by this time, the DSO noticed a rapid depletion of fuel in the aft pod fuel tank. He concluded the sheet of flame seen from the ground during takeoff was caused by fuel leaking from the aft pod tank and being ignited by the afterburner. But since we were over Fort Worth, I contacted the center. They already had us on the scope and had alerted the other aircraft traffic control facilities to clear altitudes for us. They informed me that the entire SAC command control system was standing by and had directed a tanker to rendezvous and refuel us. As there was some doubt that contact with the tanker could be established, we were told to prepare for a crash landing. We were rapidly approaching a minimum fuel condition. Contact was finally made with the tanker. Our troubles were not over, however. The nose-high attitude of our B-58 with landing gear extended made refueling doubtful. We calmly discussed the overall situation and decided to proceed to Carswell area where crash landing could be made if it became necessary. En route to Carswell, our crew developed a technique that resulted in a successful refueling. We flew at 11,000 feet. I used the outboard engines at maximum afterburner to maintain speed and the inboard engines for directional control. After communication with Carswell, the decision was made to continue refueling throughout the night and to go to Edwards in the morning, where there would be more favorable conditions for landing as well as a bombing range for jettisoning the pod. We refueled 8 times with landing gear extended. By morning, 1/3 million pounds of fuel was transferred from 7 different tankers. Anticipating our arrival, the crew at Edwards Air Force Base put down a foam-covered strip on the runway 9,000 feet long. We were now in contact with Edwards. A chase aircraft from Edwards came up to survey the damage. The first close examination of the main landing gear by daylight revealed 3 of the 8 wheels to be intact, 2 hanging from the scissors assembly, and 3 completely missing. The axle and landing gear positioning springs were both broken. accomplishing pod drop and jettisoning fuel, we were ready for the landing. I was instructed to land the aircraft with nose gear just to the right of the narrow strip of foam, so the damaged gear would be in the foam, allowing for better control of the aircraft under the existing emergency.
The crew was aware of the fact that landing could still result in complete disintegration of the remaining parts of the left landing gear, thus jeopardizing their lives. Actual films taken at Edwards Air Force Base as the crew commander brought the crippled B-58 in for a perfect landing after 14 hours in the air. The Air Force has a vast communications network backing up every operation. This frequently results in the saving of a great number of lives and millions of dollars of equipment. When we are aware of, accept, and use the principles of good communications at every level of our man-machine environment, they can be among man's most valuable assets in preventing accidents.